everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 6, Heat and Energy. We will be discussing the topics non-renewable sources of energy and energy degradations. Are you ready for this session? Let's begin. So in the previous session, we have discussed about the renewable sources of energy in detail. What are the different renewable sources of energy? We had solar energy, wind energy, energy from flowing water, then tidal energy. We discussed about ocean thermal energy, oceanic waves energy, sea waves energy. Then we have discussed about the nuclear energy, nuclear fuel as a source of energy. All these we have discussed. So these are the non-conventional sources or the renewable sources of energy. Now, today's class will understand what are non-renewable sources of energy and what are the different non-renewable sources of energy. So, what is non-renewable source of energy? It is a conventional source. This we have defined in the previous session. So, what is a non-renewable source of energy? When you are given non-renewable source or conventional source, first thing you have to remember is you cannot renew it. Okay, once exhausted, it is exhausted forever. Okay, now how are they formed? They are formed from the dead plants and animals which were buried deep under the earth for a long time. It is formed many million years ago. Okay, once if they are used extensively, what happens is, so if you are not bothered about it, what happens is one day it will get exhausted. Once it is exhausted forever. You won't get it back. You cannot reuse it. Okay, you cannot recycle it. Nothing can be done. Once it is exhausted forever. Okay, and the important thing is they can cause pollution. Okay, we have said in case of renewable resources, they do not cause any pollution, but here they can cause pollution. The sources of energy which have accumulated in nature over a very long period and cannot be quickly replaced when exhausted are called non-renewable or conventional sources of energy. Examples are fossil fuels. Okay, fossil fuels such as coal, petroleum. Okay, these are two important examples of conventional sources of conventional source of energy or non-renewable sources of energy. Okay, they are exhaustible. First, a non-renewable source that we are going to discuss is coal. Coal is naturally occurring. It is black in color and it is composed of free carbon. It contains free carbon. Then it contains compounds of carbon, nitrogen, oxygen, hydrogen and sulfur. Okay, now why is this coal used? Coal is a major source of energy which is used for heating. It is used for heating in house and also it is used in industries. Then it is used in thermal power plants. Okay, one is for heating purpose. In house and industries they are used. Next, they are used in the thermal power plants. Third, it is being used in the manufacture of coke. Then it is used in the manufacture of fuel gases. Okay, fuel gas includes coal gas, petroleum gas. So, for these and all, you can use coal. Okay, mainly in India, coal is found. That is, how do we get coal? Coal is formed out of it is a fossil fuel that is formed because of the dead plants and animals that were buried deep inside. Okay, millions of years ago. Okay, this produce coal. Now, in India, coal mines are mainly found in Jharkhand, Chhattisgarh, West Bengal, Orissa. In these districts, you can find the coal mines. Okay. Next is petroleum. Petroleum, it is a dark colored viscous liquid. It is also called crude oil or it is also called black gold. Okay, so like coal, petroleum is also a non-renewable source of energy. Okay, It is a complex mixture. What does it contain? It is a complex mixture of hydrocarbon, which is mixed with water, salt, earth particles and other compounds of nitrogen, carbon, oxygen and sulfur. All these together make petroleum. Okay, now these petroleum refineries are mainly, so how to get petroleum? This petroleum will be found under the surface of earth. In the earth crust, they will be stuck between the rocks, okay, which can be refined. Now here, there is a fractional distillation process. So from crude oil, the useful parts can be separated by the process of refining. So in refining, fractional distillation is done. Fractional distillation, mainly in Mumbai and Assam. In India, in Mumbai and Assam, you can find the refineries. So here, during the fractional distillation, we can compare the density of, when you compare the density of petroleum with water, you can see that petroleum is less denser than that of water. So it doesn't mix with water. Okay, so when you compare their density, so here, when you use a petroleum product, that is when you use crude oil, when it undergoes fractional distillation, different layers will be there, okay, which contains different useful substances. Okay, so here you will be having petroleum gas. You can separate them. Petroleum gas. Then petrol is obtained. Kerosene is obtained. Diesel is obtained. Then paraffin, wax is obtained. All these can be separated by the process of fractional distillation. Okay, now we'll be discussing in detail where these petroleum products will be used. Uses of petroleum. First one, we all know this, for transportation. For transportation inside vehicle, we are filling fuel. Which fuel is filled? Petrol. Either it will be petrol or it will be diesel. So, in transportation of running the vehicles, we are using petroleum products. Okay. So, where do you get petrol and diesel? It is from the refining, from the fractional distillation of the crude oil. Okay. Second, in power stations where diesel and gasoline are used in gas turbines to produce electricity. So, second one is power station. So, for in vehicles we are using for transportation purposes. Second is in the power station where that is gasoline and diesel. Okay, gasoline and diesel are mainly used. Why are they used? To rotate the turbines. Okay, they are used in the gas turbines, which helps in the production of electricity. Now, third is for heating and lighting purposes. We have heard about the kerosene lamp. Yes, then what about the liquid petroleum gas, LPG? Have you heard about it? So, in every house, you will be having the LPG cylinder. So, in this LPG cylinder, petroleum products are there. Okay. Next is as lubricants for smooth running of all types of machines. So, we know that there are chances of frictions. In machine, there will be chance of friction because of the wear and tear. So, in order to prevent this, what can be used? It can be used as a lubricant. Lubricant is something which will reduce the friction and make the surface more smoother. Okay, next is both petrochemical and chemical industries uses petroleum byproducts as raw materials. So byproducts that are obtained from the refining of petroleum is used as raw materials in petrochemical industries and in the chemical industries. Okay, so these are the places where you will be using petroleum products. So we have already said what is refining. So this is how the petroleum refineries looks like. So here, because of fractional distillation for crude oil is done, in which the separation is happening. The process of separating the useful components from crude petroleum is called refining, which is done by fractional distillation. The process is fractional distillation, which is helping to separate the different useful components of crude oil in big oil refineries set up for this purpose. Okay. So next is natural gas. Natural gas is found deep under the earth's crust, either alone or above the petroleum refineries. So this natural gas, it mainly contains methane. Okay. About 97% of natural gas is methane. It also contains ethane and some propane. So all this constitutes a natural gas. Okay, now what are the uses of natural gas? Uses of natural gas. First point, when natural gas in liquid form is subjected to high pressure, we get CNG, which is used as fuel in vehicles like cars, buses and trucks. What is CNG? CNG is compressed natural gas. Compressed natural gas. So compressing, what will be happen? It is turning into a liquid. From the gaseous state, it is going into the liquid state. So we know this. Okay. What is compression? Compression means we are trying to bring all the molecules closer. Okay. When you bring closer, the volume is decreasing. Okay. So when volume decreases, the gas will turn into a liquid. And this is called compressed natural gas or CNG. Where do we use CNG? CNG is mainly used as a fuel in vehicles like cars, buses and trucks. Okay. Now the second point is used alternative to petrol and diesel because it does not cause air pollution. We know that petrol and diesel causes air pollution. So if we are using CNG, which is compressed natural gas, it does not cause air pollution and therefore it can be used as an alternative for petrol and diesel. Next, the third point, it is used for cooking food, heating water, manufacturing fertilizers and to produce electricity. So these are the uses of natural gas. Okay. So it is a main source, that is, it is able to produce heat. Since it is able to produce heat, it is helping in cooking food, then heating water. Okay, other uses are to manufacture fertilizers. Then also this heat energy then can be converted into electricity. So they can be used in the production of electricity. Next is LPG or liquid petroleum gas. We all are familiar with this. So the petroleum gas that is obtained from the refining of crude oil or petroleum contains mainly three gases, that is, first one butane. Butane C4H10. Then propane C3H8. Then ethane C2H6. So these are in the gaseous state. Okay, they are existing as gases. So these gaseous state substances can be converted into liquid. So to convert it into liquid, what is then? It is under pressure. So under pressure, this gas gets converted into liquid and they can be stored. So this is called liquid petroleum gas. The petroleum gas liquefied under pressure is called liquefied petroleum gas or liquid petroleum gas or LPG. So why do we use this LPG? LPG is a fuel that is being used for the cooking purposes. You all know in every one of your house this Bharat gas or some other gases will be available. So here it contains, this is LPG cylinder, it contains gas which is liquefied petroleum gas. Okay, so this liquefied petroleum gas can be used for the cooking purposes. Now what are the differences between renewable sources of energy and non-renewable sources of energy? Renewable sources we have discussed in detail in the previous section. Now we have discussed about the non-renewable sources of energy. Yes, you remember? Okay, now what are the differences? First is the definition itself. These are sources from which energy can be obtained continuously. They are from nature directly over a long period of time. They don't get exhausted. Okay. Second, that is non-renewable sources of energy. These are sources from which energy cannot be continuously obtained over a long period of time. Next is the second point. These are non-conventional sources of energy. Okay. These are non-conventional. What about this? They are conventional. Renewable, non-conventional. Don't get confused. If it is renewable, then it is non-conventional. If it is non-renewable, then it is conventional source of energy. If you can renew it, then it is a non-conventional. If we cannot renew it, it is a conventional source of energy. Next is, these are natural sources which will not get exhausted. Inexhaustible they are. What about this? These are natural sources which will get exhausted with time. These are also natural, but what is the thing? So coal, petrol, all these are we are getting from the nature, that is from fossil fuels. But the thing is, it will get exhausted with time. Okay. Next, these sources can be regenerated. It can be renewed. Okay. What about this? These sources cannot be regenerated. Okay. One is can, the second is cannot. So just remember these points. That is first one. They are non-conventional. Then this is conventional. If they are inexhaustible, these are exhaustible. These are regenerated, they cannot be regenerated. Next, examples: sun, wind, tides, ocean, nuclear fuel. All these are examples of renewable sources of energy. What about the examples for non-renewable sources? Just we have discussed coal, petroleum, natural gas are examples for non-renewable sources of energy. So there are 5 important points. If you just get an idea, you can just compare and write them. Judicious use of energy. What does it mean? So these energy sources should be used carefully. You should not spend them as you wish. Okay, use it judiciously. So why is this done? Only then for the future we will be having these resources. Okay. So first point, the fossil fuels such as coal, petroleum, etc. should be used only for limited purposes when no other alternative source of energy is available. We know that the energy from sun will be obtained till the end of the universe. Yes. What about wind? What about water? All these we know it is indirectly dependent on the sun. So once sun is there, you will get all these. But what about the case of coal and petroleum? One day they will get exhausted. So only if there is no other source of energy available, only in that cases you should make use of them. Okay, so it is best to depend upon the solar energy if it is possible, because solar energy will be there till the end. But that is not the case of coal and petroleum. Once they get exhausted, we won't. It is exhausted forever. Okay, next second point, wastage of energy should be avoided. So have you heard your parents saying, don't keep the light on, don't keep the fan on? Why do they say this? Because it is to save energy. You should not waste energy. If you waste energy now, for the future there won't be energy. Okay. Second, the third point is cutting of trees must be banned and more trees must be planted. Okay. So you have heard deforestation. So in deforestation, what is happening? All the trees are being cut. When trees are cut, it will lead to greenhouse effects and global warming. So in order to prevent this, more and more plants, more and more trees should be planted. Okay. Next, fourth point, efforts must be made to make judicious use of energy in the community. So among the community, there should be some campaigns or posters should be created and classes should be given to people. So you have to inform them. So posters should be made such that no cutting of trees. So what are the importance of this? So how should energy be used? All these types of classes should be given to make people aware. Next is the judicious use of energy. The fifth point is the use of energy in the urban areas is much more than in the rural areas. So in the rural areas, people directly depend on the sunlight, then wind energy, hydro energy and all. But in case of the urban areas, people depends on the non-renewable sources of energy or the conventional sources of energy. So here normally we say that the use of energy is more in the case of urban areas because they want more electricity. Okay. So in case of rural areas, so just if you compare, in rural areas, man will work more. Okay, but in case of urban areas, machines will work more. So machines to work, there is a need of electricity. Electricity is a source of energy, which means in urban areas, the machines are working more, therefore the electricity and hence the energy used is more. Next point, such techniques should be developed by which in your future we may make use of renewable sources such as solar energy, wind energy, hydro energy, bioenergy, oceanic energy, etc. as much as possible to meet our energy requirements. So without depending more on the non-renewable sources, some method should be developed such that techniques should be developed such that we are more dependent on the renewable sources, because renewable sources will not get exhausted anyways. But that is not the case of non-renewable. We have to be very careful while using the non-renewable sources of energy. Next, efforts must be made to obtain nuclear energy by the controlled nuclear fusion of deuterium nuclei present in heavy water available in sea. So this is a method that can be used to produce energy. But we have discussed about nuclear fission and fusion reaction. Using fission reaction, we know how energy is produced. That is in nuclear reactors. The slow neutron, that is the neutrons which are produced, can be controlled. It can be on rods and moderators with the help of all these in the nuclear reactor. So we can control. Okay. So by controlling, what can be done? The energy is used to produce electricity. But we don't know how the energy is used. The fusion energy is used. So methods can be developed. Okay. Effort should be made to use the nuclear fusion energy as well. So that when if you are able to produce energy, then this is also a possible way. This is even though it is a renewable source of energy. We know that this is a renewable source of energy. It can also be put into use. Okay. So effort should be developed for that. Production of electricity from solar energy. What is solar energy? Energy from sun is called solar energy. We know this is a direct source and it's a most vast source of energy. Okay, so there are two devices which convert solar energy into electrical energy. One is a solar cell. It directly converts the solar energy into electrical energy, and then you have solar power plant. These are solar heating devices which converts the solar energy into electrical energy. That is, electricity can be produced using a solar cell and a power plant. Okay, so we'll discuss them in detail now. First, we'll discuss about solar cell. When sunlight is incident on selenium, what happens is electric current is produced. Okay, so what is a solar cell? Solar cell is, in simple words, is a device which converts solar energy into electrical energy. To make a solar cell, usually semiconductors are used. What are semiconductors? Semiconductors are devices which shows properties of both metals and non-metals. They are intermediate between metals and non-metals. So when you speak about the conductivity, you can say that the conductivity of metals is the highest, it is the lowest in case of insulators, and when you take the case of semiconductors, the conductivity of a semiconductor is less than that of metals and greater than that of insulator. At room temperature, you can see that is at low temperature or room temperature, you can see that conductivity of semiconductor is very low. But when the temperature increases or you add impurities to the semiconductor, its conductivity increases. Okay, so for example, silicon is a semiconductor, so you can make a solar cell using a silicon. Then you have germanium is the semiconductor. Then you have gallium is a semiconductor. So these are all semiconductors and they can be used to make a solar cell. Okay, so when you take a solar cell, okay, let's say of about 4 centimeter square area. Okay, 4 centimeter square area. So when sunlight falls on it, what happens is a potential difference is created. Okay, this potential difference will be about 0.4 volts to 0.5 volts. In that case, because of this potential difference, an electric current will be produced. Okay, approximately 60 milliamperes of electric current can be produced. Okay, when you have a solar cell of area 4 centimeter square. Now, this is only 60 milliampere. Okay, if you want more current, what should be done? Many such cells should be used. Okay, when you use many such cells, you can produce more current. Okay, so when you take one cell, another cell, many cells, we keep it together, we call it as a solar panel. Okay, so this is a solar panel. You can see many solar cells arranged in this. Okay, so got an idea about solar cell. Now we have understood how a solar panel looks like. That is, when you arrange solar cells together, you get a solar panel. Now my question is, we know that solar cells can be used during the daytime because we have sun. Sun is the source of energy. Electricity can be produced. What about the night time? Can you produce electricity using the solar panels during the night time? Is it possible? No, right? Why? Because during the night time there is no sun, there is no solar energy and electricity cannot be produced. In that case, a storage battery is used. Okay, in the storage battery during the daytime, what is happening? The energy will get stored. Okay, and it can be used during the night time to produce electricity. Okay, so this is how it looks. That is a solar cell which is used to pump water. Okay, this is how the setup is. So here you can see you will be having the solar panel. Sunlight is falling on the solar panel. These are the small solar cells. Then you have a battery in which, this is a secondary battery in which the energy gets stored. Here you have underground water. So underground water should come out. It should rise. Okay. For that you have an electric motor. So this is an electric motor. So when electricity is produced, this electricity from solar energy helps to bring water, help to pump water. So understood? So this is an application of solar panel. Advantages of using solar panels. They do not require any maintenance. So here you can see how a solar cell is made. How a solar panel is constructed using solar cells. They are just semiconductor devices. Silicon, germanium and gallium are being used. Okay, sunlight is also available. Daily you will be getting sunlight and you have a storage battery there to store the energy for the night time to produce electricity. Second is they last over a long period of time. Okay, they are long lasting. Third, their running cost is almost nil. So here you can see directly the source is sun. Solar energy, the source is sun. So sun's energy, to get the sun's energy, we don't need any cost. Okay, so the running cost is almost nil. There is nothing that much costly to set up a solar panel. Next, they are most suitable for the remote, inaccessible and isolated places where electric power lines cannot be laid. So you can see that too, if electric power lines cannot be laid, you can use the solar panels. That is, sun's energy can be directly taken and the electricity produced can be used for different purposes. So it is more helpful in these cases, okay, in remote areas or isolated areas. They do not cause any pollutions in the environment and are the cleanest source of electricity. So directly the sun's energy is being used. There is no chance of pollution at all here. Okay, no smoke is produced. Okay, no pollution is being produced here. So it is the cleanest source of electricity. So these are the advantages of solar panels. Now what are the disadvantages of using solar panels? So we have discussed about solar panels. The initial setup is very high. Okay, so first point, the initial cost of solar panel is sufficiently high. This is a disadvantage. Okay, second, the efficiency of conversion of solar energy to electrical energy is low. So what is efficiency? How much effective it is? Okay, that is when you use a device, we will check its efficiency. Okay, how much is the outcome? We will check, right? So here when you take the case of a solar panel, its purpose is to convert solar energy to electrical energy. Yes, so its efficiency is very low compared to other devices. Okay, for this conversion to happen. So this is the second disadvantage. And third one is a solar panel produces DC electricity. What is DC electricity? Direct current is being produced, which cannot be directly used for many household purposes. For household purposes, alternating current is being used. Okay, so direct current cannot be used. This direct current should be converted into alternating current. Only then for household purposes it can be put into use. Okay, so this is also a disadvantage. Solar power plant. Solar power plant is also a device which uses heat energy to produce electricity. A power plant is a device in which the heat energy of the sun is used to generate electricity. So in case of a solar power plant, there will be concave reflectors. So what is a concave mirror? A concave mirror is a mirror. They are spherical mirrors in which you can see that this is how it will be. When light rays falls on concave mirror, okay, what happens is it will get concentrated at the focus. So next chapter we will be discussing this in detail. We will be discussing about the reflection in case of concave and convex mirror. So here you can see light rays which are falling on a concave mirror will get concentrated at a point. So we have heard that from the sun's, using the sun's light, you can burn a piece of paper. Okay, you hold a paper in your hand. Okay, then you take a concave mirror. Okay, hold it towards the sun. The sunlight should fall on the concave mirror. So here the reflected rays will get concentrated at a point. At that point, if you are keeping a paper, what happens is the paper will start to burn. Okay, because of the heat that is concentrated at this point. Okay, from the sun. Same thing is happening in the case of solar power plants. You can see in solar power plants there are many concave reflectors. Okay, so what happens is the sunlight which falls on it will get reflected. Okay, it will get reflected and it will get concentrated at a focus. Okay, so at this place, so here we can use to boil water, to heat water. This can be used. Okay, so if you are having a black pipe, okay, a black pipe, if it is kept at the focus, what happens is due to the heat, okay, due to the heat, the water will start boiling. It will start, the water inside the pipe will get, it will start heating the water inside the pipe. Then what happens? Boiling means it will get converted into steam. This steam will be used to rotate the turbines, and when the turbines rotate, electricity is generated. Okay, this setup was installed in Gurgaon and Haryana, which was able to produce 50 kilowatts of electrical energy. Okay, so this is all about solar power plants. Production of electricity from wind energy. Wind energy is a kinetic energy of wind. Okay, that we have said already. What is wind? Wind is a moving air. Okay, now you can see that this is a setup. Here you will be having a generator which is placed on a pillar. Okay, there is an armature. You are providing magnetic field. This is a turbine. Then you have a shaft. Okay, at the end of the shaft you will be having the blades of the windmill. So here what happens when the wind strikes the blades? Wind is having kinetic energy. This kinetic energy of wind will get converted into the rotational kinetic energy of the blades. rotational kinetic energy of the blades. So the blades will start rotating. So when the blades rotate, with the rotation of the turbine, what happens? An energy is produced. Okay, so here you can see this is the dynamo, this is the armature. Here what happens is you are providing magnetic field. Okay, with the help of this magnetic field, a current here produced is alternating current. An alternating EMF will be produced. Alternating EMF is produced. Okay, this is how the electric generator is. Okay, now what happens is the power that is produced from a single windmill will be very small. Okay, that is the electric current that is produced from a single windmill will be very small. So, for producing more electricity, to produce electricity in a large scale, what should be done? More windmills are required. So, more windmills when installed at the same place, we call it as a wind farm. Okay, that will be a wind farm. So, here when you compare it with the solar cells, you can see that in case of solar cells, the electricity produced is DC electricity, which cannot be directly used in the household purposes. But when you take the case of the windmill, okay, using this wind generator, we are producing alternating current. Alternating current can be directly used for household purposes. Okay, what are the advantages of using wind energy? First one, it does not cause any kind of pollution. So, the same thing we have studied in the case of solar energy also. Okay, there also no pollution is produced. First point is this. Second is it is an everlasting source of energy. So we have said that the energy from sun is everlasting. Yes. So sun's energy is being used to produce wind. Okay, there will be difference in density. The sunlight reaching at different point will be different. The heating at different places will be different. Because of the heating, the air's density will be different. Then what happens? There will be move of air. The air will start moving. Moving air is called wind. Okay, wind will be blowing from one place to another depending on the density. Okay, so we know that until we have sun, there will be wind as well. So this is also an everlasting source of energy. Okay, next, the limitations of using wind energy. First, the wind farms can be established only at places near the coastal areas where wind blows around the year steadily with a speed not less than 15 km per hour. So, to produce wind energy, to produce electricity from wind energy, what is required? Wind is required. Okay, where wind is available. Okay, it's not just that wind should be available. It is necessary that the wind that is blowing, okay, the speed of the wind that is blowing should not be less than 15 km per hour. Okay, only if wind blows at a steady rate and the speed of wind is greater than 15 km per hour, only then in coastal areas it will be possible to produce electricity, or you can establish the wind farms there, or the windmills can be established there. Now, second point, a large area of land is needed for the establishment of a wind farm. Okay, just to keep one windmill, it is easy. But to produce more electricity, what we need? Many windmills are required. So, when many windmills together in an area, we call it a wind farm. So, you need a large area to establish a wind farm. So, this is the second disadvantage. Third is establishment of a wind farm is expensive. Okay, the initial cost is very expensive. So, these are the disadvantages of, or the limitations of, wind energy. Production of electricity from flowing water or hydro energy. The most important use of hydro energy is to convert it into electrical energy, okay, by using turbines. So, here turbines will, this is a setup. That is, in the case of dam, we know in dam, using the dam water, we can produce electricity, okay. Then what you can see in the river, okay, in a dam, in the river you will be able to see that the water is at great heights, okay, water will be stored at great heights, okay. So, here they are stored at great heights, then they will be possessing potential energy. So, what is potential energy? Potential energy is mass into acceleration due to gravity into height. Okay, so when height increases, when this is at a big height, what happens? The energy stored, the potential energy stored will also be higher. Okay, this energy will be now converted into kinetic energy when the water from the dam starts flowing. Okay, so this flowing water, what happens? It possesses kinetic energy. So when potential energy is high, the kinetic energy of the moving water will also be high. Okay, this kinetic energy can be used to rotate the turbines, okay, to rotate the blade. So here you can see you have a water turbine. This is a water turbine. It gets rotated. At the end of the shaft, these blades are found. Okay, then you have the dynamo or the armature for that is to here we have the electric generator. So what is a generator? Generator is a device which can be used to produce electricity. So we have heard about generators. Generators use other sources to produce electricity. So here we have a generator or dynamo. Now because of this rotating turbine, what happens? We are also providing magnetic field. So inside a dynamo you have north and south poles. Okay, now an alternating EMF will be produced. This is how electricity is produced. Alternating EMF is produced. Okay, this is how electricity can be produced using the hydro energy. Water which is stored at a great heights in dams are used to produce electricity. And the electricity here produced is not the DC electricity, it is also alternating current. So in case of wind energy, wind turbines we have discussed, and in case of the hydro energy that is produced by using turbines. Okay. In both these cases, you can see that the electricity produces AC electricity. The alternating current is produced which can be used directly for household purposes. Okay, so this is about hydro energy. Advantages of using hydro energy. First point is the same that we have discussed in case of wind energy and solar energy. Even hydro energy does not cause any pollution. It does not produce any environmental pollution. Now, the second point is it is a renewable source of energy. What is a renewable source of energy? We have discussed in detail. So, hydro energy is also a renewable source of energy. Renewable means it will be long lasting. That is, it can be renewed. It can be reused. Okay. Now, third one, the dams constructed over rivers help us in irrigation and control floods in rivers. Okay, so dams are very helpful. Okay, when you construct dams, you can use these dams. It is used mainly in the irrigation purposes, and also it is helpful in controlling floods because the rainwater harvesting and all you have heard, right? So in rainwater harvesting, what is happening? The water is getting stored in dams. Okay, and this water can be made useful. Okay, you know that the rainwater can cause floods. Okay, to an extent, these floods can be controlled by the construction of dams. Okay, and the water in the dams can be used to produce electricity. So the rainwater is made useful here. Disadvantages of using hydro energy. This point we have discussed in case of wind energy also. You cannot install or you cannot establish the wind farm at every place because their wind should blow at a speed greater than 15 km per hour, and we need steady winds. Okay, the similar point you have for hydro energy as well. The flowing water is not available everywhere. Only where you have dams, where you have rivers, you can construct. Okay, you can construct dam and produce hydro energy. So this is not possible at every places. You need water which is stored at heights. You need dams. Okay, so flowing water is not available everywhere. This is the first point. Second, due to the construction of dams over rivers, plants and animals of that place gets destroyed or killed. So when you construct a house, you know that the field should be, that is the plot should be first cleared. Okay, so there you will be removing all the plants, all the trees will be cut down. Similarly, to construct dams as well, the life, okay, that is animals, plants, all the lives are destroyed or killed for its construction. So this is a disadvantage. Third, the ecological balance in the downstream areas of rivers gets disturbed. So in rivers, aquatic life. These aquatic lives also gets disturbed because of the construction of dams. Okay, so these are the disadvantages of using hydro energy. Okay, so for every sources of energy, we have advantages and disadvantages. So both should be checked. Production of electricity from nuclear energy. We have studied about the nuclear fission and nuclear fusion reactions. In nuclear fission and nuclear fusion reaction, we know that a tremendous amount of energy is produced. Okay, so here what happens is, in a nuclear fission means splitting and fusion means combining. Okay, in a nuclear fission reaction, a fast moving neutron strikes a radioactive substance like uranium-235. Then what happens? 3 neutrons are produced, 2 similar nuclei are also produced, that is barium and krypton. Okay, and a tremendous amount of energy, about 200 MeV of energy is produced. So here what happens is the neutrons produced, 3 neutrons that are produced can go and strike the other uranium atoms. Again many neutrons will be produced. Okay, 3 neutrons, when it strikes 3 different uranium atoms, for each case 3 neutrons will be produced. Total 9 neutrons will be produced. These 9 neutrons will now go strikes 9 other uranium atoms. Okay, then what happens? 27 neutrons will be produced. So this is a chain reaction. It is a continuous process happening. This should be controlled, and it can be controlled in a nuclear reactor. So this is how a nuclear power plant looks like. The main part of a nuclear power plant is a nuclear reactor. Inside the nuclear reactor, you can see here we have the cadmium rods. Okay, and this cadmium rods helps to control the chain reaction. This continuous process can be controlled. Then you have a graphite block. These are uranium rods. Okay, so here heat energy will be produced. The energy produced is heat energy. Here we have a coolant. So this heat energy will pass through the coolant. Okay, now this is a heat exchanger. Okay, the coolant will be absorbing the heat energy, and it passes through the heat exchanger. Okay, when it passes to the heat exchanger, what happens is the water in the heat exchanger will start getting heated up. Okay, when it start getting heated up, what happens then? Steam will be produced. The steam produced will now move to the turbine. Okay, so blades of the turbine will rotate. Here we have the shaft, and this is a generator. So when this rotates, okay, when the blades of the turbine rotates, armature coil here in the generator rotates. You can see the magnetic field. Okay, so with the help of the magnetic field and the rotation of the armature coil, electricity will be produced. Okay, this is how electricity is produced in case of a nuclear power plant. Got it? So this is a setup. Advantages of using nuclear energy. First one, a very small amount of nuclear fuel such as uranium-235 can produce a tremendous amount of energy. Only a very small amount of uranium is required. Okay, if you have a uranium atom, that is uranium-235, it can produce 200 MeV. If the number of uranium atoms present is higher, what happens? The amount of energy produced will be higher. So using nuclear fuel, here the nuclear fuel is used as a radioactive substance, uranium-235. You can also use plutonium. Next, second point is, once a nuclear fuel is loaded into nuclear power plant, it continues to release energy over a long period of time. Yes, so when you load it inside a nuclear reactor, the same can be used for a long period of time. So these are the advantages of nuclear energy. Now what are the disadvantages of using nuclear energy? It is not a clear source of energy. Why? Because here it is a radioactive substance that is producing energy. So radiation, nuclear radiations are produced which are not good for health. That is, it can affect the human body. These radiation can cause tumors, it can cause cancer. Okay, so these radiations are very harmful. So a high standard protection is required. This is the first disadvantage. Second is, the waste obtained from the nuclear power plants cause a high degree of environmental pollution. So this is causing pollution. So when you discussed about the cases of solar energy, wind energy and hydro energy, it doesn't cause any pollution. But this is not the case with the nuclear energy. It causes pollution because they are radiations. Okay, so the nuclear waste that is produced, it cannot be disposed easily. So they get decayed over time, and it can cause more environmental pollution. A high degree of environmental pollution will be caused. Energy degradation. So just take the case of an electric bulb. Okay, we have studied law of conservation of energy. Energy can neither be created nor be destroyed. It can only be transformed from one form to another. In case of electric bulb, what is happening? Here you can say that electrical energy is getting converted into light energy. Is it only that light energy is produced? Is there any other forms of energy? So there should be a complete conversion. But here I am saying that only 25% or less than 25% of the electrical energy is getting converted into light energy. What about the remaining 75%? Where does it go? It is getting converted into other forms of energy. So after some time, when you go and touch this bulb, you can feel heat. So what does it mean? From the electrical energy, heat energy is being produced. Yes. Can you use this heat energy anywhere? So light energy is used. Electric bulbs, main purpose is to produce light energy. So this light energy is used. But what about the heat energy that is produced? Can you put into use? No, right? So it is getting wasted. This is called energy dissipation. Okay. Now, when you take the case of a moving vehicle, in case of moving vehicle, what is happening? Chemical energy is getting converted into mechanical energy. Yes, but is it only mechanical energy? No, again in this case also there is dissipation of energy. Okay, heat is produced, smoke is produced, noise is produced. It is causing friction due to the wear and tear. Yes, so in all these things energy is getting lost and these cannot be made use. Can you use the noise that is produced anywhere? The sound energy produced anywhere, can you put it into use? No, right? Heat, can you put it into use? No, right? So what is energy degradation? Energy degradation, when you take the case of bulb, over a long period of time what happens is the useful energy will be decreasing and the undesirable form of energy will be increasing. So when you take the case of electric bulb, the desirable form of energy that is produced is the light energy and the undesirable form of energy produced is the heat energy. Yes, so this is a degraded energy. The undesirable form is a degraded energy. It is a waste energy. Okay, so we can define energy degradation as the gradual decrease of useful energy due to the radiation loss, friction, etc. is called degradation of energy. Okay, so here we have discussed the first case. In the second case, it is friction. Okay, due to the friction, what is happening? There is energy loss. Okay, there is energy dissipation. Yes, this energy, there is a wastage of energy. It cannot be put into use. So, over a long period of time, what will happen? Because of the fuel, okay, chemical energy. Normally here, chemical energy should be converted into mechanical energy. Energy should get converted into mechanical energy. So, what happens over long periods? The efficiency of the vehicle will decrease. Efficiency means if an ideal device is something that will completely convert the first source of energy into the second desirable form of energy. But there is nothing that is ideal. Okay, in that case efficiency will be 1. Always for every device's efficiency will be less than 1. There is no device in which there is no wastage of energy. The complete transformation is not happening. Okay, so during the motion of this vehicle, you can see there is wastage of energy. So we can say that it is not 100% efficient. Okay, next for cooking, you will be using the LPG, you are using the fuel. Okay, here again, there is wastage of energy. Heat is produced. Heat is one source of energy. Okay, there are other forms of energy that is wasted. They are undesirable forms. Okay, when you keep your mobile for charging, what is happening? Here you can see that energy is getting stored in the battery. Yes, electrical energy is used and this electrical energy is getting converted into chemical energy and is getting stored inside the phone. Plus, heat is produced. After some time, what happens? You can see that the phone will start getting heated up. Okay, you can see, or 2 years or 3 years, you are using the same phone. The heating will increase. That is the energy. The degraded energy is increasing. Okay, and you will be able to see that to get a battery charge, it will take more time. Okay, so the useful energy, that is the chemical energy produced, is decreasing, and in that case, the degraded energy is increasing. Okay, so this is energy degradation. That's all for today. In today's class, we have discussed in detail about the non-renewable or conventional sources of energy. Then we have discussed the production, judicious use of energy and the production of electrical energy from the different sources, that is solar energy, wind energy, hydro energy and nuclear energy. We have also discussed energy degradation. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.